Have you ever actually looked closely at those massive towering tires on a construction site or, say, down in a mining quarry? To the untrained eye, they kind of just look like giant slabs of black rubber, right? But there's actually a high-stakes, secret language hidden right there on the sidewall. It's a code that literally dictates whether a multi-million-dollar piece of machinery is going to operate safely or end in absolute catastrophe. So let's dive right into this. Welcome to today's explainer, where we are going to decode the DNA of heavy machinery tires. Here is our quick roadmap for today. We're going to cover the secret language of tires, crack the letter codes, look at the very real danger of swapping tires, decode the numerical suffix, and finally put it all together to read a complete tire. All right, Section 1, the secret language of tires. So let's talk about those mysterious alphanumeric codes stamped on these massive pieces of engineering, what the industry calls off-the-road or OTR tires. Have you ever noticed letters like E3, L5, or maybe G2? A lot of people just assume they're, random factory tracking marks, maybe a serial number or a batch ID, but they absolutely are not. These combinations are actually a crucial safety warning and an operational guidebook, all rolled into one. As outlined in our source document, PTK 101, Practical Tire Knowledge, this whole coding system is designed to prevent one very specific critical error: putting the wrong tire on the wrong machine. We're going to use this document today to break down exactly how this system works and why ignoring it is pretty much a recipe for disaster. Moving right along to Section 2, cracking the letter codes. Every OTR tire application starts with a letter. But before we get to the letters themselves, we need to know who actually sets the rules here, right? Well, that would be the TRA, which stands for the Tire and Rim Association. They are the governing body that established this global industry standard. It doesn't matter where you are in the world, a construction site in Dubai, a mine in Australia, or a busy port in New York, the TRA coding system is the universal language keeping those operations safe. Okay, let's walk through these primary TRA letter classifications. First up, we have E for earth mover. Think of your massive haul trucks and articulated dump trucks, the ADTs. These tires are built for transport cycles over long-haul roads at moderate to high speeds. We're talking up to 50 kilometers per hour. Because of that speed, they are structurally designed to dissipate internal heat very rapidly. Next is L for loader. Wheel loaders, dozers, that kind of equipment. Their life is totally different from an earth mover. They do short-distance pushing, digging, and loading at very low speeds, usually under 10 kilometers per hour. So they don't need to dump heat, they need to survive sharp rocks. To do that, they feature incredibly thick, cut-resistant sidewalls for heavy load stability. Then there's G for grader. Motor graders are all about ground leveling. Their tread pattern really prioritizes directional traction and precise steering control. And finally, I and D for industrial. You'll see these on compactors or straddle carriers working in paved industrial ports. Their operational duty focuses on bearing really high static loads and ensuring a long overall tread wear life. So you can see how fundamentally different, say, an earth mover's high-speed transport cycle is from an industrial compactor's static load. It's like comparing a marathon runner to a power lifter. Which brings us to Section 3, the danger of swapping tires. Now, this is where things get really interesting and, honestly, pretty intense. There's this huge misconception on job sites that if two tires share the same physical size dimensions, say 23.5R25, you can just easily swap them between an ADT and a wheel loader. No problem, right? Wrong. In reality, their internal engineering properties are completely opposite. Let's actually pit them against each other for a second. The E tire is engineered for speed and heat. It uses special heat-dissipating compounds and flexible sidewalls. The L tire, on the flip side, is engineered for load and cuts. It features massive tread thickness and extremely thick, rigid sidewalls. So they might look exactly the same on the outside as far as physical dimensions go, but internally, they are entirely different beasts. Think about it. If an operator mounts an E tire, that fast, heat-dissipating, flexible one, onto a loader working in a sharp rock quarry, that tire is going to get cut and completely destroyed. It simply doesn't have the armor for that kind of fight. Conversely, if you take that heavily armored, thick, rigid L tire and mount it onto a fast-moving haul truck running long transport cycles, well, the tire simply cannot dissipate the heat it generates. The internal temperatures will skyrocket, and the tire will suffer a catastrophic blowout due to heat. We are talking about severe, life-threatening safety hazards here, and thousands upon thousands of dollars instantly vaporized, all just because the wrong letter was chosen. All right, Section 4, decoding the numerical suffix. So we've mastered the letters. Now let's look at the numbers that follow them. The number right after the TRA letter, like the 3 in E3 or the 5 in L5, designates the tread depth and the severe duty rating. Think of this as basically an escalating scale of toughness. Number 1 is rib. These are straight ribs, best for sand or smooth rolling surfaces. Number 2 steps it up to traction. These have lug patterns for optimal directional grip on things like soft mud or clay. Number 3 is rock. This is your standard tread depth, ideal for general quarries. Number 4 is deep rock, giving you a serious layer of extra cut protection. And finally, number 5 is extra deep rock. These are built to survive the absolute harshest, most brutal rock face and mining conditions on the planet. Just to give you an idea of how drastic this escalation is, let's look at the jump to a number 4 tire. A level 4 deep rock tire features a tread that is literally 150% thicker than your standard level 3 rock tire. That is a massive injection of rubber, specifically engineered to act as a shield against sharp, destructive debris. But wait, it gets crazier. Jump up to a level 5 extra deep rock tire, and you are looking at an astonishing 250% thicker tread than the standard rock tire. When a massive machine is operating at the jagged, unforgiving rock face of a deep mine, it absolutely needs this absurd level of thickness just to survive a single daily shift. Let's wrap it all up with Section 5, reading the complete tire. Now we get to bring the two halves of our anatomy breakdown together to validate everything we've covered today. By combining the environment letter and the severe duty number, you are reading the complete DNA of that tire. For example, an L5 tire is specifically built for a loader operating in extremely harsh, sharp rock environments at very low speeds, relying on that massive 250% thicker tread to resist cuts. Meanwhile, an E3 tire is built for a haul truck moving at higher speeds in a general quarry, prioritizing heat dissipation with a standard rock tread. So here's a question for you. The next time you drive past a major construction site, or maybe see footage of a sprawling mining operation on TV, don't just look at the sheer size of the tires. Look closely for those letters and numbers. Will you be able to decode the DNA of the massive machines working around you? Because now you know. That simple E3 or L5 isn't just a random label. It's a literal marvel of engineering, an absolutely vital safety protocol, and the secret language that keeps heavy industry moving safely. Thanks so much for joining me on this explainer, and keep learning.